Okay.
In what?
Yeah, so you're not seeing my notes page, you're seeing...
No, I'm not seeing your notes.
Not that I've made any notes, but... I'm going with the flow here.
Go with the flow.
Going with the flow. You see that? So you see that. That's nice.
That's the webinar page, yeah.
Oh, there we go. There's the my little webinar chat thing has finally caught up. There we go. Okay, people are coming in. That's good. Where's my other thing? That's that. Ah, there we go. That's the thing I was looking for. I know if people are in. Okay, people are coming in. Just sip my coffee a minute.
Yeah.
You're still loud, Pop. You want to mute yourself or?
Yeah, can do. I should just wave if you mention me.
No, you can speak if you want. You know, it's just don't cough down the microphone in my ears. All right, 93, 94, 95. Hello, everybody. Good morning, Mike and Heather and Nick and John and Richard and Paul and Mark. And we check that you can all chat to each other. You can. Excellent. All right. Well, good morning, everybody. Is it Thursday today? Yeah. I've lost track of time. Well, I hope you're having a wonderful Thursday morning. And I'll be honest, I am knackered. I am a little knackered. So I'm on the coffee. This webinar is just to talk through Amendment 1, really. It's kind of strange. It's not an electric vehicle course kind of webinar, but it's all about it because we're talking about Amendment 1, which is obviously heavily focused on Section 722. So what we're going to do in this one is just kind of talk through Amendment 1. Going to talk about some of the changes from the 18th edition as we get there, but really it's just a kind of just to talk through the content of the amendment. That's it, really. That's what we're going to do. So I will. People are still coming in. All right. Okay. We'll start. Okay. So, Amendment 1 came out a couple of months ago now, and you know, it was a brief moment that everyone got prepared for. It was just a rewrite of Section 722. The information in the amendment tells us that it can be immediately implemented, but it actually needs to come into compliance from the 31st of July for the erection of these installations. So designing now, but if you're going to erect starting from the 31st of July, that's when it needs to be in effect. There are obviously some of these changes, though. The reason it was rushed, we hear, is mainly because the government wants, obviously, to get these things installed, and so there was extra effort to get this thing finished. I mean, we are now on, I think, the 4th edition of the IET guidance on this. If you've, I think that's just not long been published because it's new technology. It's constantly re-innovating itself. Regulations have had to try to keep up, and we've pushed this, but there is a couple of regulations mentioned in there that kind of give free license for the manufacturers to keep being creative to achieve protection. So if you actually start looking at the top of Amendment 1, accessing Amendment 1, if you're not aware, you can access it for free on the IET website. It has like big watermarks on it, and you can pay, I believe, £5 to then be able to produce to print the document. So you can access it and reference it for free, and then you can give them some money to pay for it. I guess it really depends on if you need it right now in your document, or you can just reference it until you purchase another book, really. The changes in there, obviously, because it's all about 722, it's all about electric vehicles, but obviously there are little changes in part 2, the definitions of, would be added. There's some changes in the index because there's references to 722. But that's it. It's all references to 722. So there's nothing else going to happen through the main structure of the book at all. In the scope, it tells us that the particular requirements apply to circuits intended to supply electric vehicles for a charging purpose. And it still has the same mention of it doesn't include systems that employ inductive charging. This is still very much in its infancy as a technology. So it's, if inductive charging takes place, then that's kind of great from a safety perspective with regards to the absence of trailing cables, but it is in its infancy. So it's still there as it's, an exclusive of scope. And again, charge mobility scoopers are 10 amp or less. Now, in the 18th edition, it did say, let's move my cursor here, that there was a consideration about the potential for feeding the supply back from the vehicle to the public or private supply network. These are all under consideration. And they've been under consideration for the life of 722, which I think came out, was it the Second Amendment, I think, of the 17th edition, 2013 time maybe. It's always been under consideration. Now, that actual note has been removed in Amendment 1. Nothing's been added technically, but if you actually do a little bit of research, if you're in this, you already know that things like vehicle to grid have been implemented as strategies that are right now being heavily invested into the commercial sector. The idea of vehicle to grid, in a nutshell, to summarize it, is we're going to look at obviously charging our vehicle up. But then when we're done with our vehicle, we've used our vehicle, we've got home, there's still peak demands on the network and on the grid. And so we can actually offer that energy back onto the grid. And obviously the meter will go both ways with regards to the way the data is analyzed. But then, so it'll discharge from the battery. So we will feed back onto the grid. And then at night time, when there's lower demand, we will then take that back for a lower rate. So it's supposed to be a good financial solution. It's worth looking into, but this is the point. We're going to go both ways here. Okay. This helps obviously with, capacity issues on the network grid, which these are going to create by adding loads of demand. Now, I have discussed this in previous webinars where we've looked at obviously the future of the industry, and we've looked at the idea of prosumer and storing energy. All of this is relative. All of this is very relative with this. This is an example of a charging point that's been set up for vehicle to grid. You can see the vehicle to grid enabled there. With regards to the maximum demand area, it used to say in 7601, in the 18th edition, it used to say that, right to the bottom here, diversity may be allowed for dedicated distribution circuits supplying multiple electrical vehicle charging points if local control is available. I should say local. So we don't really apply diversity demand. We did mention this in a recent maximum demand video webinar that we've done. That was the assumption that if we were going to put in lots of electric vehicles charging points into one infrastructure, we could maybe have load control. So if we pull on one and then we're going to pull on the other, then it would obviously dampen down that demand. This has been rewritten to a very, very simple term now, which basically says load curtailment, including load reduction or disconnection, either automatically or manually, may be taken into account when determining maximum demand on the installation or part thereof. This is heavily relying on, obviously, communication with the control equipment. To summarize curtailment, this is an action similar to demand response, with the specific removal or reduction of electrical loads for limited periods of time for the utility grid system to obviously request you to take less, so allow the grid to actually operate. There are two parts to this. There's load curtailment, and we also used to mention a term very early in the life of 722 called load shedding, I think it was called, which was like another step of this process. The idea being that when there are large periods of demand, fundamentally, there's not an infinite supply of electricity. We should know that as electricians. We should know that when we put too much demand on, the grid is going to suffer. So there need to be arrangements in place to allow us to arranged to actually dampen down our demands to allow the grid to actually cope with that excess demand in other areas, maybe even geographically. So this technology will have that setup implemented to it, and that kind of takes a lot of the work out for electricians, because we don't really have to quantify if it's set up to do that, because technically the grid can also communicate with the charger to say, okay, you can have more, and then it can die down when needed. And I'm sure it's worth looking into a little bit of your own CPD if you're involved in designing electric vehicles. I'm not sure if there's going to put more content on this in the guidance with the IT soon, but it's something that's been in discussion a lot lately.
David?
Yeah.
This harkens back to the discussion that we had with Paul a couple of days ago. Reference this business of load shedding and these automatic devices that are going to come in to divert.
All very smart stuff, yeah.
Yeah, all the smart stuff. We're talking about, because we've got excessive loading beyond the maximum capacity of the installation, we're going to have these automatic, or allegedly automatic devices, which are going to divert the energy to where it's going to be needed.
Yeah, because let's remember that also, with the suggestion that gas boilers are going to be removed from new homes, there's going to be excessive demand there electrically. So we're looking at multiple sources of generation and storage. So we have to, this is a new evolution of the way we utilize electricity.
Especially considering that some people may have multiple points. Most households, a lot of households these days have 2 cars, sometimes more. And if we're going over to electric vehicles, then if you can imagine the demand there's going to be every time people come home from work and want to charge their vehicles up.
That's key, and that's the problem. So it needs to have this sensible understanding that we can't just turn it all on when we want to. We have to obviously plug it in at times when everyone else is going to be plugging in, and so we're going to get less to actually support the network, because we just can't put all of that on the network at the same time. And so you may even know, in the real world, what you might notice is if you go home when everyone else goes home, your car takes a bit longer to charge. But if you arrive in the middle of the night, it might charge more rapidly, because again, the load will be relative to the stress on the grid, and that's what the curtailment will help to achieve. Okay, so going into the area of protection. Now, the area of protection has been one that's been chewed on and worked on a lot over the past few years, and that's because of the of this issue of the PEN conductor. So TN systems. So we're going now into, we're not yet in the protective section. We're in 722.312, which is obviously the conductor arrangements, but it just says there that a circuit supplying charging equipment for electric vehicles will not include a PEN conductor. Now, this illustration shows the problem that we have with PEN conductors, which obviously we relate mostly to TNCS systems. And we have the open PEN conductor, not neutral, the protective earth neutral, the combined protective and neutral conductor there. And that creates that problem where once that breaks down, the voltage will rise to earth off of that. And that can obviously create dangerous circumstances. And if you've done BS 7671, you'll understand that this is a similar situation in caravan parks, marinas. We just don't take PEN conductors out to plugs that we then would go to a mobile transportable unit, to a caravan, and obviously it's going to be the same for cars. So what we've done in the previous circumstances, though, we've just converted things to TT systems, and in caravan parks and things like that. That's fine. There's obviously been questions about the safety of that with electric vehicles, because the electrodes going down much closer in the home to underground pipe work and obviously your PME cable. So we'll see in a minute where the regulations doesn't quite like that idea of always converting PME to TT systems in section 722. But all of this issue here, this PEN conductor, has created the requirement for protection, and it's something that they've been redeveloping technology over the past few years, and it's had to create a little bit of a rewrite in this. So we enter into protection for safety, protection against electric shock. So the first thing you can see is the common thing that you see in all of Part 7 special locations, where those protective measures, obstacles, placing out of reach, non-conducting location, all those, they're not acceptable. Yeah, that's the same for all special locations. Those are specialized protective measures, so they are not suitable. It then starts by introducing protection against electric shock by again saying that a PME earthing facility is not to be used as the means of earthing for the protective conductor contact of the charging point, okay, located outdoors. All right. There are a couple of obviously exceptions to this. So it starts off by saying no. So if you're on a TT or a TNS, then that's fine. This is TN Systems PME. Let's get that out there first. So we're looking at TNCS situations. So one of the following circumstances has to be present for us to consider being able to use a PME. The first recommendation is where the charging point forms part of a three-phase installation that also supplies loads other than electric vehicle charging. And because of the characteristics of all of these loads, the maximum voltage between the main earthing terminal of the installation and earth in the event of an open circuit will be lower than 70 volts. So what we're basically saying with this one is, if we can assure ourselves that this system is three-phase and very well balanced, then in the situation of an open circuit on the pen, which basically means neutral loss, we don't want to have a scenario where there are lots of currents on the neutral, because that's going to result in a rise in the voltage. So if we had a system where there were no currents in the neutral flowing, because the system was perfectly balanced in three-phase arrangement, then in the potential absence of a neutral due to a broken pen conductor, there technically wouldn't be any increased level of problem here. This is really just a regulation that's there because of the science, because it technically would work in theory. But the question is, how is that achievable to actually balance loads equally on a three-phase system?
I was just going to say that
Yeah.
it's an almost impossibility, because even if you balance it on paper, as loads switch on and switch off on your system, then your phases are going to become unbalanced. So it's almost an impossibility, that, unless you're supplying just one piece of equipment, a three-phase motor.
Yeah. The science works, the theory works, but the practicality of this is just a non-starter for most in this. And everyone kind of goes past this one. The next situation is where, and this is all from the previous, this is all in the 18th edition, where the main earthing terminal of the installation is connected to the installation's earth electrode by a protective conductor, complying with 544.1.1. That just means it's 544.1.1. That, I believe, is the regulation for the sizing of the main bonding on PME or non-PME. If you go to the beginning of the bonding sizing section, so it's sized to that. The resistance of the earth electrode to earth shall be such that the maximum voltage between the main earthing terminal of the installation and earth in the event of an open circuit. Again, this is the value here. We are not to exceed 70 volts. And you'd have heard this one, and everyone will say to you, you're not going to do that. You're not going to be able to achieve that value of voltage because, and there's a good annex now, which is still there, but it's been updated. The annex has been updated in Amendment 1. So you'll notice in the annex that they've got these little values such as Cmax. Okay, this is the formula that's used in the annex. Now, I've just worked with it. I've played with it a little bit here. So we've got the RA of the electric vehicle, the RA or the electrode to the electric vehicle point must be less than or equal to 70 times the UO times Cmax. And we can see Cmax is a factor given for the maximum voltage factor, considering voltage variations. Now, does that sound familiar? A factor for voltage variations due to transformer taps, etc. But this is not a Cmin, this is a Cmax. So unlike in part 4 where we went with a Cmin to consider the potential of a drop in voltage, which would achieve insufficient current for ADS, here we're actually thinking about, well, we want to make sure we have no more than 70 volts, so we've got to consider the potential maximum voltage. So what the Cmax does, you can see the factor here is 1.1, is in the formula, it changes the 230 to the peak of that, which I think is 256. Yeah? Oh, sorry, 253. It pushes it to the peak voltage that we have allowed in our voltage range in BS 7671. Okay, that's a little tweak to this from the previous edition. So in this little example I've got here, I've taken the formula from the annex and I've thrown in a magic number of 85. The INST, or the INST, is the maximum demand current of a single phase installation in amperes, including that of the electric vehicle. So it's the maximum demand of a single phase installation with the added demand of an electric vehicle. And I've just gone with a magic number of 85. That's just a magic number that I've thrown in. Now, you can do this again and again, with your own magic demand number for a single phase installation plus an electric vehicle demand. And you can see what you come up with. So when you crunch this together, you'll notice you'll only come up with about 1.1, 1.2, 1.3. You'll be coming around about 1 ohm, 1 to 1.5 ohms of area. And this value that we're calculating here is supposed to be the maximum value of RA of the electrode that we actually install to actually reduce that voltage area down in the area of the electric vehicle. And so you'll see a lot of people will go, it's just not practicable to actually achieve that low an RA. Most often, a single rod is most likely not going to achieve that. So people will start saying, well, yeah, you need to move on because the electrode method is just not very easy to achieve to get a guaranteed RA that's low enough in ohms to achieve. And the goal here, obviously, is that the voltage won't go over 70. That's the point. That's why 70 is stuck in that formula now. Okay, so the conclusion with this second option of putting in an electrode near the actual charge point. Remember, that's not converting to a TT system. This is connecting onto this on the PME. This is not a conversion to TT. The conclusion, therefore, is that this is going to require a much more elaborate earthing. So maybe if you're going to redo your driveway, you may want to put a mesh in there. You may achieve that with a much larger mesh or earth grid. Who knows? It might, depends on your real estate, really. So, and the other thing is obviously driving the electrode down. If we can avoid that by installing devices, then you're going to see people show you things like, risks of driving spikes into the ground and having arc flashes occur. If we could potentially break through and hit underground service cables, and that's unavoidable, we should try to avoid that. So we've got two areas that will complain about the impracticality of this little regulation. It's hard to achieve the low enough RA, and there is an increased level of risk driving electrodes down. So that's the second option here, the idea of putting an electrode in. These are both from the old 18th edition. Now, we had this third one, and there's not much change to it except for the guidance. So this is, unfortunately, it's lots of words, and I have to read it, I'm afraid. So here we have a device, and it's going to electrically disconnect the vehicle from the live conductors of the supply from the protective earth in accordance with 543.3.3.1012, which actually means if you go to devices that switch the protective conductor, this device has to switch the protective conductor after the live, and it makes them before. A bit like how we would switch neutrals, we must make sure the protective conductor is not disconnected first and reconnected last. That's just the switching requirements of a protective conductor. That's what goes into that regulation there. And it must do this within 5 seconds in the event of a voltage and CPC going to 70 volts. And it has to happen in a period of time, not less than 4 and no more than 5 seconds. Or sorry, not less than 4 and 5 seconds with this. So we had, in the life of the 18th edition, some devices come out that tried to actually achieve this. We started to say things like unicorn device, but then other companies started to go, well, this does this, this does this. We used to call it a unicorn device, then some manufacturers brought devices that achieved this, but now with the 18th edition Amendment 1, they've added guidance. And the guidance actually says in the annex that this describes a device measuring the voltage between the CPC of the electric vehicle charging point and earth. That's a big E. So that's got to be a measurement to true earth. So during a pen fault, the supply network, the neutral of the TNCS, is no longer considered to be reliably connected to true earth. Therefore, it's not suitable for the device to actually take measurements to the CPC in neutral and to the CPC in the consumer unit's main earthing terminal. We need to actually find a way to take a measure. So these are not suitable, those two connection methods. We need to find a way to take a CPC to a suitable measurement earth electrode. So a little electrode that comes off of the device that goes into earth, true earth, okay? We've seen a device recently that does claim to do this, and we have tried to look into it further. It looks a bit rubbish. So right now, this device, which was in the 18th edition starting to come up, this guidance has been added that mentions these earth electrodes that have to go in, and there's further guidance about the distances between them, etc., which basically makes the modern electric vehicle charging points not really achieve this. So it's gone back to kind of being a unicorn device. It's being described that way still now. So that's not quite what these modern devices are doing. The new one, this one's had a lot of debate. And this one says, first of all, single phase. So protection against electric shock in a single phase installation is provided by a device which electrically disconnects the vehicle from the live conductors of the supply from the protective earth in accordance with 543.3.3.1. The same thing, must disconnect the CPC after and then make it before within 5 seconds. If the utilization voltage at the charge point between the line and neutral is greater than 253 or less than 207. So we're starting to use voltage monitoring. So voltage monitoring is the way to protect with this method. The device will provide isolation and be selected in accordance with table 537.4. That's the table back in chapter 53 that tells you about devices that are suitable for isolation, functional switching. Yeah, it just means it should be recognized as a device for isolation. Equivalent means of functionality could be included within the charging equipment. Closing or resetting of the device will be possible only if the voltage between the line and neutral is in the range. So it'll only operate if the present voltage between line and neutral is within the legal limits that BS 7671 has. A couple of problems with this, and I couldn't find a good way to display this in the time frame that I had. I'm going to recommend you look at a couple of manufacturers because they've done a lot of effort to kind of explain the issue with this regulation. We're relying on voltage monitoring to take place between line and neutral and assuming that if there's a loss in the pen conductor, that would then take that installation's voltage below or outside of that area, and it will then just identify that and go off. Here's the problem. This is for single phase installations only. Because if this was for three-phase installations, you could actually have a varying demand on other phases. And what that could mean is I could have so much demand on one phase that the neutral actually is no longer in the center where you think it would be. And so when you have an open pen, the actual neutral has shifted over, and whilst the loads are pulling on one of the phases, maybe the phase that your electric vehicle charging point is connected to, the voltage might stay in that window of 207 to 253, whilst another one might go up over to 300 volts or go down below 100 volts. You know, it's proportional to the demands of the other phases. And the problem that has is if your device is just monitoring one phase of a three-phase system, other phases can pull up and down different demands. So the earth and neutral voltage could rise over these values of over this amount of 70 volts. It could rise over 70 volts, but the voltage detected is still within this window. Okay, now that's why this is a single phase installation requirement. The problem is, and this is something that manufacturers like Zappi and Matti have tried to kind of get people to think about, is if you think about your houses in your street, you're going to have three houses next to each other. Whilst there are three single-phase installations, they are still technically connected to the same three-phase supply. So if you think of them as a three-phase installation, if you have an electric vehicle charging point on your system and the pen conductor to all three homes has gone down, the actual demands are not the same, and the demands on the other two houses could be a lot greater or a lot less. So the voltage monitoring on your device will be proportional to the other demands of the other properties. And that does mean that the monitoring of the voltage is really right now in serious debate. One of the guys from Zappi, Dr. Chris, I can't remember the rest of his name, he actually did a bit of a campaign about the concern with this specific regulation. So when you see these new modern devices and the way that they detect and they monitor voltage, this is part of the process, but they actually go beyond that. Okay, and I do stress that you do a little bit of reading up on other manufacturers' methods to protect. A lot of it is patent pending, unfortunately, which does keep a bit of it, you know, hard to read and hard to trace. So there has been some serious concern with dysregulation. I do recommend you do some more reading up on this one. So where does that leave us? Because we've said, well, the first one, 3-phase, isn't practicable. The bonding one isn't practicable. The third one's a unicorn device again, because we need electrodes to go off and connect to monitor. This one's not that great. So what we have is this other one, which is the 5th one. And this says, okay, protection against electric shock is provided as an alternative device to those given in 3 or 4, the unicorn or the one we've just discussed, if it achieves the same level of protection, so no lesser degree of safety. So manufacturers kind of have free license now to create devices that they feel adequate as long as it achieves the key requirements of protection for this section. And those are that the closing and resetting of the device shall be possible only if the voltage to the earth and the CPC is not over 70 volts. And within 5 seconds in the event of utilization voltage of the charging point going outside of our allowances of 207 to 253, that has to operate. And finally, the device has to be an isolator, has to be recognized as an isolator in BS 7671. So these are the 3 key protection criteria that devices that manufacturers bring out have to do. Now, some of them, I know, for example, Zappi have their own little, it's like a residual current detecting monitoring system, but it's not a RCD. They've got their own little current monitor, and they've got electronic equipment that does that. But this does require a bit of trust on the manufacturer's basis. So make sure the manufacturers give you as much transparency as you feel you need from them. I say I've mentioned Matt-E and Zappi because Matt-E actually don't make charging points. They make devices that go with charging points to achieve protection. And Zappi obviously do make charging points that have this protection in there. These two have probably from my research, these have great transparency about the issues with the regulations and how they are seeking to comply with the regulations. Okay, so you've got to stay with this because, again, this is new technology, new innovations. Just to complete the TN system part of the protection, it then says, protected conductors and exposed conductive parts that are downstream of our device that is used for 3, 4, or 5 in that scenario. So the one that's now a unicorn again, the one that is single phase voltage monitoring, or the 5th option, which is something that does those that isn't in the regs. Then any protected conductor or exposed conductive parts of any circuit not protected by the same protected device, okay, or any extraneous conductive part, these will not be connected downstream of protection because we then compromise protection. So once the protection has been established, we don't then reconnect it to another potential earth, such as a supplementary bond to a water pipe. So most often you'll find that the protection will be either adjacent to the charging point or in the charging point itself, so that your protection downstream is just to the vehicle. Now, mentioned earlier on about TT earthing, and this is a note that's right at the end of the TN system, the TN protection. And it says, creating a TT earthing system for charging equipment or the whole installation as an alternative to using the PME in one of the methods given just now in 1 to 5. It may not be an appropriate solution due to the inability to provide sufficient separation from buried metalwork connected to the supply pen conductor. So if I've got cables and pipes under the ground and I've got a PME, the electrodes in that PME are obviously creating a lot of common reference to the surrounding groundwork. If I then strike an electrode in close proximity to any of that reference, if the PME goes down and obviously the earth around becomes the reference for what would have been the neutral, then there may be a close proximity to my installed electrode that I might start to pick up that increased voltage potential again. Even though I've installed a TT system, it's right next door to a PME, or it's been buried into what you might consider to be PME's ground. And if I bury the electrode into PME's ground, then it makes sense that when there is a failure in the PME and the ground becomes reference due to the open pen, that the electrode I've installed might start to pick up that reference. So again, if we want to convert to TT systems, what we need to do is achieve some level of distancing from any underground pipe work or the PME system itself. So you may have this option if your charging point is maybe on the other side of a customer's carport or car parking bay. So you can take a PME out and then export it to a TT at that end. But if you create your TT at the building where all of the other underground infrastructure in the PME is, you're likely not to achieve sufficient protection by just converting it to a TT itself. Okay, so that's the TN requirements for protection. It then goes on to talk about electrical separation. This is more than acceptable. A fixed isolating transformer, the 61558. Biggest problem with it is cost, and it's a bit of a obstacle. It is a bit of an obstruction. But it is an option. It's, there's nothing wrong with using it as long as you work with electrical separation properly. External influences, 512.2. It's simple now. IPX4, IP4X, therefore IP44. Those are the requirements. Obviously, if you're going to go into an area that might have higher levels of cleaning, like jets, then you may increase that, to IPX5. But this is the minimum for outdoor. Okay, there's no mention of requirements for indoor. There is a consideration of impact severity, AG3, if we're going to put electric vehicle charging points in public areas or carports or car parks, obviously because these charging points are not designed to be bumped into by vehicles or other risks of heavy impact. So we may have to put in some bollards, well, we will if it's outside, just to protect it from any excessive impact from vehicles pulling up to park next to them. So there is a mention of an external influence there. Moving into RCDs, this is the other interesting area. It says it'll disconnect live conductors. That makes sense. And unless you've used electrical separation, you have to have each charging point incorporating a socket outlet or a connecting vehicle connector will have to have a 30 milliamp RCD. Okay, obviously electrical separation is isolated from Earth, so that shouldn't be necessary. Obviously, in all other scenarios, we're going to need a 30 milliamp RCD. Now, unless the electric vehicle charging equipment has protection against DC fault currents internally, then we need to think about DC currents. Now, with my work with the E5 guys, we've been talking about DC leakage into the AC network a lot, and we've been stressing about the need to consider type A RCDs over type AC RCDs, and we can see that demonstrated here. So it actually says we want to think about type B as our first choice. We could use a type A or type F in conjunction with, this is a fun one, a residual direct current detecting device, an RDCDD, complying with BS IEC 62955, an RDCDD. Okay, it's a detecting device for residual current. And what that kind of does, there's a standard for it, which I've obtained, read, and I need to read it again. It kind of supports, type A obviously does up to 6 milliamp pulsating DC. This kind of gives it a backup support. Yeah, it kind of supports type A RCDs. Okay, for 6 milliamp fault currents for DC. So again, manufacturers will use a variety of options. If you use charging points that have internal protection, then that process or that decision-making process should have been made for you. Overcurrent protection, we just need to make sure we have suitable overcurrent to 609.472, 609.4762, or 610.091, which is an RCBO. Or we could use relevant parts of 60898 or 602.69, relevant parts being just overcurrent protection. Okay, it's worth noting that it does say that electric vehicle charging equipment may have multiple charging points. So it might be that you have multiple charging points from one, so you may have to have, in that case, you'd have individual overcurrent protection, like with all scenarios, like even with caravan parks, the overcurrent protection would be individual. Protection is always individual in that scenario. With socket outlets and the connectors, there are a couple of options now. We've got obviously this one that's a BS13632, basically a 13 amp socket outlet. Now, there's been some debate about this, because obviously, you know, you go to buy an electric vehicle and they'll say you just plug it in at home and you get what's called a granny cable, which is that 13-amp cable. It's really designed to trickle charge and top up your electric vehicle. It's not really great to just plug it into a typical 13-amp socket. But they do manufacture, I think Hager and a couple of others have actually branded them for such a purpose, 1363 socket outlets with electric vehicle markings on the back or on the front, and they're designed obviously to carry larger. We think of a typical twin socket outlet is tested at 20 amps. These are sometimes, you know, pushed to 25 amps. If you can find one that's pushed 25 amps as standard, it's just going to be able to tolerate the stress of the larger demand for the longer duration. We're seeing a number of examples coming up now where people have been plugging the vehicles in, and then after a period of time, there's excessive heating around the plug and socket, because the plug and socket is not really considered appropriate for that duration of demand. So they do manufacture specific sockets that are actually made for that to 1363. You could use a 60309 too. This is just your standard C form, interlocked, and then you can use 60309 or 4 for self-contained connections. The point being with those is that you cannot touch the live contacts when you're inserting the socket. This is the problem. You know, if you're going to insert the plug or the socket up to the vehicle, you can touch the contacts. That needs to be completely avoided. Then we have what we're commonly familiar with, which is the vehicle connectors themselves, type 1, type 2, type 3. Obviously, we have a variety. Depends obviously on the process of charging. Different requirements, different processes of charging. There's a mention that one socket outlet or vehicle connector shall supply one vehicle. Yeah, 1 for 1. And if we're using charging modes 3 and 4, that is obviously where we're using control and communication and higher charging currents, then it'll be assured that we can't unplug or plug in to the car or the actual charging point unless the socket outlet or the vehicle connector has been switched off from the supply. So we don't unplug it whilst it's pulling many, many amps. That makes a lot of sense. Okay. Mode 1 is just a standard plug and socket outlet. That's really not favored. Mode 2 is the lowest we'd like to go, and that's a plug and socket arrangement, but there's control and communication and protection in the lead. That is it. That is as far as it goes with Amendment 1. There's no mention of any extra requirements for testing at all. So I've got no other content from 722. I'm seeing, obviously, you've got dedicated test equipment to test charging points. I've seen that there's dedicated leads that you use with Rolec, and there's Mitrel have got a dedicated tester. So, Pop, what do you think? Why don't we actually have any dedicated reporting in BS 7671 for this?
I think we're still playing catch up. I think the technology is so new. The technology is changing so quickly. I'm looking at the comments from a lot of the guys. There's been a lot of discussion about the different manufacturers, the different types of equipment.
It really is.
I think we are still playing catch up. Technology is changing rapidly. I mean, I've got a few things here. I mean, why are we looking at 70 volts? Why is this? The voltage shouldn't exceed 70 volts. Where all the way through the regs, we've always talked about touch voltages of 50 volts, and 50 volts being the maximum voltage which is safe.
Yeah,
so where's this 70 volts suddenly come from?
There's a standard they reference, and the explanation they give is that that's the voltage for a hand-to-foot journey, not a hand-to-hand.
So why are we using 50 volts elsewhere?
It's something.
Is it because we're outdoors, maybe?
It's something I've looked into, and I've looked at where they've taken information from, and to me, it's just a study. They've taken it from a study that said about the potential for 70 volts to be similar to 50 volts with that journey. I'm still skeptical, to be perfectly honest with you. I've got all of the these standards about electric shock on the human body. There's dozens of them. I've had a look at many of them, and it's just tables and tables and tables, and I can see where they're getting it from. But I just can't help but think that hand-to-hand potential is very likely in some circumstances.
But maybe because it's outdoors, they're talking about hand-to-foot potential and 70 volts. But then why aren't they using the same voltage on things like caravan parks? marinas and stuff like that, why isn't there the same mention of 70 volts there?
Who knows? Who knows?
That's outdoors.
Maybe.
So I honestly think the IET and the powers that be are playing catch up with this, and technology is so new. The technology is changing so quickly and so rapidly. They're still thinking about ideas. I was looking at also this business of 722.411.4.1, which talks about PME system should not be used. It doesn't say change it to TT there. It says that you put an earth electrode in alongside your PME. So, and then when they're talking about if you do change to a TT, you've got to look at your electrical separation, of your earth rather than the exposed conductive extraneous conductive parts. But there's no mention of how much separation. So electrically, if we shoved a rod in, we could do a measurement from that to the fixed installation earthing and the extraneous conductive parts and take a resistance measurement. But there's no mention of that value.
I did some reading, and some people have come up with guidance such as 2 meters and 4 meters. There is some guidance in the annex in 722 on some distances, but it's all relative to your own earthing, your own ground.
Yeah,
and that is, that is the issue with that. And so
it is, as I say, it's a new. I thought, we've had these things for ages, but it is still a new technology in many ways. And I think science is changing, and I think the IET is struggling to keep up with things.
This is why I've said
to give us the right information.
This is why I've said go to companies like Matty and Zappi, because these guys, it's their bread and butter. These innovations are important for us to know. They want nothing more than for us to understand how they're interpreting these protective requirements. And there was a lot of passion from Dr. Chris Chap from Zappi, because he was frustrated with the suggested amendments. He was going around basically saying, that this I think this is unsafe, and that's it's nice to hear that kind of honesty from manufacturers, and the more we can hear from manufacturers, the better. But this is one of those sectors where the manufacturers will dictate where the regulations end up. And fortunately, I guess, because the manufacturers will give you much more information earlier.
Yeah.
Which, as we know, for electricians, is what you're going to lean on when you take a design and you're going to go, well, I've got loads of words, loads of maths, loads of formula. If you can find a manufacturer that says, "Oh, we comply with this," you can take that. As long as obviously that they're verifying it to the current version. So now you want to make sure they're saying it complies with BS 7671 2020. Okay, so it's fully up to date. And this is implemented. This has to be implemented from July, of this year. So this is a good example of where the industry really does just follow the direction of industry, from manufacturers, and also pressure from the government. Obviously, pressure from the government to drive this technology in. We had obviously the incentives. I think they've messed that around, or they've reduced the actual incentive. But I'm trying to keep up with it. But you go back to the web page, there's new information every time.
There's been lots of comments, which is great. It's good to get communication going. Dean sort of mentioned that the Tech Talk, the NIC Tech Talk, covered the 50 volt and the 70 volt.
Did they say hand to feet?
Well, I haven't actually read. I haven't only looked at the Tech Talk, but as I say, my sort of question is, well, if we're using 70 volts here, why aren't we using 70 volts in caravan parks?
It raises other areas.
Pavel said about the fact there being a 3.6 meter separation in one of the guides. But the thing is, of course, with a PME system, if you've got multiple earth points all the way down your neutral conductor, you don't know where the nearest spike is. So you might be going 3.6 meters away from your building or whatever, and you could actually be going nearer to an earth spike that's been put in by the DNO.
That's why and that is why they have obviously tried to raise this concern with us driving electrodes in when there's an existing PME. It's definitely a different area of risk than just being completely in the middle of a field or disconnected from a building. A lot of these charging points are fixed on the outside of the building. And if we put an electrode right beneath it, we're most likely going to be very close or in the earth groundwork that is still, it belongs to the PME, because the PME has those references, doesn't it?
Yeah, so, well, I mean, they generally earth them every 30 meters or so.
Yeah.
But of course, that's 30 meters going up the 3-phase cable. If your house is right next to one of those earth spikes, you don't know, do you? Unless you know exactly, or you've watched that cable go in from the electric company, which is nonsense. You know, it's just not going to happen. But I think, you know, that you were coming back to the fact of, as with all things, and it's written in the regs anyway, that we follow the manufacturer's instructions, and that's about the best guidance we can get at the moment is going by the individual manufacturer's instructions.
It is, yeah.
And following the regs as far as we can with the information they do give. But I think the manufacturer's instructions for these devices are going to be really, really, really important.
Yeah. There's some mentions there about John Ward. Yeah, JW. He did a good video on Amendment 1. He's done some videos on charging points. He's making so much stuff about SPDs right now. But I'm actually speaking to him later.
Good, yeah. John's on top of things.
He's put up great content about electric vehicles. This is definitely one of those areas where you just need to make sure that you are tapping into the right resources. And I don't think BS7671 or is it? I mean, the 4th edition of the IET Code of Practice has just been republished, and apparently I've not got it yet. It's not in my my vital source thing, but apparently it has gone another level compared to the older ones. I've got the older ones here, so yeah, I can't actually speak for it, but I hear it's gone. You know, it's gone up a level. I don't know. Has anyone got the 4th edition in the chat?
Can't see, but
No.
Yeah. I think there's not yet. There's a few. Yeah,
He's just
saying.
Yeah.
I think the thing is, I mean, what's obvious from this is it's actually started more questions than answers, which is actually great because communication is king, and I think, you know, as an industry, we need to start saying, look, you know, what's going on with this? We need proper direction. We need proper instruction and regulation. Otherwise, you know, it's all very, very, very confusing, isn't it? The different advice we're getting from different manufacturers and from different sort of techs. So
yeah, it is, and it's this decision to try to obviously not convert to TT, to utilize PME, but create these different protective measures. I think this is having the biggest, not confusion, but the biggest area of why is this happening for this area, with the technology to kind of taking over. There's a comment here. When doing the EV course, I was told you have to contact the DNO on every install. How many charging points are going to be installed without speaking to the DNO? So how will they know about the demand on the network? This is very true. I mean, the DNO need to be aware of the stresses put onto their network. So isn't it part of the process with RELEC to tell with the registration of the government to inform the DNO? Is that not part of the process? I don't know. I know people that have signed up to that, and the paperwork for that process.
Getting information from the DNO, as we all know, is almost impossible, because if you ring them up and you talk to somebody in the office who's probably never been out of the office at all, so trying to get proper information from them at all is almost impossible.
Cool. Yeah. All right, EO. Okay. Well, I think I'm going to wait until I get this 4th edition to actually then put something together on electric vehicles, because then I can reference that. I'm hoping to get that, you know, any day. Then we could do one on electric vehicle charging installations. This is just Amendment 1, which is all about electric vehicles, but it's a bit different.
Yes, I think once that comes out, we'll hopefully fill in the gaps, because I was actually quite disappointed by this amendment. When I first saw this, I thought, is that it? I was expecting much more from it, because the original 722 left me with loads and loads of questions. Yeah. Thinking, well, hang on, we need more information. No, when the amendment was coming out, I thought, fantastic, but even more questions. Yeah.
No, the first one was quite wide open. What this one's done is it started to close around the direction the manufacturers have created, but it's not quite gone with, you know, dedicated routes. But yeah, we will come back. We'll come back to this subject with some more when we get some more information on it. And we'll be back later on today for one on observations, recommendations. It's more of a discussion. You know, we did one on Tuesday where we talked about testing. We're going to come back to that subject. We're going to talk about inspection, testing, observations, coding. We'll have some slides to show, but it's mainly going to be talking scenarios. So bring your best cases to the chat and we'll discuss and we'll see what we think.
Hopefully be lively.
Yeah.
Thanks very much.
All right. See you later.
Take care.
Thanks, guys. Bye-bye.